Sets, class 11th. Today we will learn about finite and infinite sets, null set, singleton set, subset, equal sets. The definition of these words we will study today. First of all, here finite and infinite sets. So in our mind it will come that what is finite set and what is infinite set, or what are finite sets and what are infinite sets. So first we will go for finite set. In infinite and finite set, first we will go for finite set. So finite set can be defined as a set is said to be finite if the number of its elements is finite. What is this? A set is said to be finite if the number of its elements is finite. I mean that if its elements can be counted one by one with the counting coming to an end. If you count one by one the elements of the set, it will come to an end. For example, if I take here a set A is equal to 1 2 3 4 5. So if I count one by one, here this is 1 2 3 4 5, so we can count this one. By counting, the set will come to an end here, counting coming to an end here. So such type of sets are nothing but finite set. So for example, again you can take the set of letters in the English alphabet is finite, since it has only 26 finite elements or 26 elements. Okay, so in alphabet ABCD, how many are there? Totally 26 are there. That is also finite set. The set of all multiples of 5 less than 1000 is a finite set. Okay, like that any set you can give the example. Next we will go for the infinite set. So what is this infinite set? A set is said to be infinite if the number of its elements is infinite. That is what here, a set is said to be infinite if the number of its elements is infinite. Means number of elements will be infinite. That is, if we count its elements in that set, given set, one by one, the counting never comes to an end. For example, you take here the set of or the set of natural number, the sets n natural number, q rational number, z integer are all infinite sets. Why it is like this? Because the number of natural numbers, how many elements present in natural numbers, we can't count one by one. If you count, you can't count all the elements. So this natural number, rational number, integer, real number, these are all what? These are all infinite sets. Okay, so in another way you can say finite and infinite set are nothing but a set which is empty or consists of a definite number of elements is finite. If it is a definite number of elements is called finite, otherwise the set is called what? Infinite. So there should be a finite number of elements you can count. If you count, there should be finite elements, then it is finite set, otherwise it is infinite set. Next we will go for null set. What is that? Null set. Null set, we can say that void set also, void set, or you can say empty set. Void set or empty set or null set, and it is denoted by 5. The null set is denoted by 5 sometimes, or we can denote like this also, empty braces like this. So you can say a set having no element is known as a null set or void set or empty set. Okay, so what is the definition here? Definition of null set is, next one, this null set, a set having no element in the set is known as null set. Okay, for example, you can take one example here. Null set, you can take example. What you can take any example. Okay, so I will take some a which is equal to x, such that x is an integer and x square is equal to 2. So which is equal to what? This is 5. You don't have any integer which is, if you square it you will not get 2, so it is null set. So another example we will take, another example you can take for a null set. What is that? A set some b which is equal to x, such that x square is equal to 4. X is odd. Can you have odd number here, x? Then here b is empty set, because the equation x square is equal to 4 is not satisfied by any odd value of x. You can't give any odd value here. Okay, so here it is, b is empty set. Okay, next we will study singleton set. A set having only one element is called a singleton set. So in a set only one element it should present. For example, you can take a, this is a singleton set, so you can take like this also. 0, it is not a empty set. Okay, it is a singleton set. If you take like this also, so for empty set is denoted by this, so this is also a singleton set. Okay, these two are singleton set, they are not null sets. Okay, please remember these two are very important. Okay, so you can take like this one more, so -1, this is also a singleton set. So you can give the name like this. Okay, b is equal to k is equal to c is equal to, like that you can give. So these are nothing but single sets. Okay, so single set means in a set only one element it should present. Okay, next we will go for subset. Next we will go for, what are subset here? Suppose think that a and b are the sets. If a and b are two sets such that every element of a is also an element of b, then a is called a subset of b, and we write a is a subset of b. A is a subset of b, like this we are writing. Okay, so thus you can say that here in another way. Thus you can say here a is a subset of b means, if x belongs to a, some element is belonging to a, means it implies what? That x should be belongs to b also. Means if a and b are two sets, a and b are the two sets, so that every element of a should be the element of, every element of a should be as in b. Okay, for example, if you take, let a is equal to 1 2 3 4 and b is equal to, you can take 3 1 4 2. So a is a subset of b. So see here, can you say here what is that subset? You can take here, 1 is there, yes. 2 is there, yes. 3 is there, yes. 4 is there, yes. So a is a subset of b, you can say. So one more example you can consider here. This is an example. One more example you can take. A is equal to 3 4 and b is equal to 1 2 3 4 6. Okay, so now see here, 3 is there, yes. Each and every element of a should be in b, then only you can say that a is a subset of b. Next we will go for the equal sets. Next we will go for the equal sets or equality of sets, both are same. Okay, equality of sets, we can go. So what are equal sets? two sets A and B are said to be equal if and only if they contain exactly the same elements. Okay, so two sets consider A and B are said to be equal if and only if they contain what they contain exactly the same elements, and we write A is equal to B. So whatever the element present in A, that element should present in B also, and the same number of elements should be there. Then we can say that A is equal to B. Okay, so here in symbols you can write A is equal to B if and only if x belongs to A. That implies what? X belongs to B also. And also you can say that x belongs to B, that implies x belongs to A. So here right, you can take a symbol like this also. You can say x belongs to B, x belongs to A means that implies x belongs to B. If x belongs to B, then x belongs to A. One example we will take so that you will get the idea. Like one example we will consider. For example, A is equal to 1 2 3 4 and B is equal to 3 4 2 1. So see here, how many elements are there? 4 elements are there. Here 4 elements, and one is belongs to A means one belongs to B. Here 4 belongs to B means 4 belongs to A also. So each same elements are present here. So you can say that A and B are equal sets. A is equal to B, you can say. Okay, like that you can take another example. So take this example. A is equal to x such that x square is equal to 1 and B is equal to 1 comma minus 1 you can take. So here also then you can say that if A is equal to x such that x square is equal to 1 and B is equal to 1 comma minus 1, then you can say that A is equal to B, because here 1 and minus 1 you will get 1 here. 1 square 1 minus 1 square 1. So in this set also 1 and minus 1 will be present. Here also 1 and minus 1 will be present. So you can say that here A is equal to B. So one more example you can take. If A is equal to 2 and B is equal to P such that P is an even prime number. Correct, even prime number. So here A, in the set A only 2 is there. Here B is in B, P is a even number means even prime number means here you will also get 2. So here also 2, here also 2. So you can say that, then you can say that here also A is equal to B. So this is how what we studied, equal sets or equality of. Thank you.